Very good. So I find the slope, which is definition y2 minus y1 over x2 minus x1. In this case, it's 0 minus 4 over negative 3 minus 3. Do we agree so far? And the top is negative 4. The denominator is negative 6. So the simplified form is 2/3. Would we agree? Did you all get that slope? Okay. Next. Since none of these points is 0, comma, a number, I will not use y equals mx plus b. I will use y minus y1 equals the slope times x minus x1. Because the given points, none of them is the y-intercept. Can you still use that? Yes, in a roundabout way. There is no need to do that, though. So I have the slope, which is 2/3, and I'd like to use negative 3, 0. So then y minus 0 is y equals 2/3. X minus negative 3 is x plus 3. Do we agree so far? All steps clear? Okay. I have to distribute 2/3. So y equals 2/3 x plus 2 over 3 times 3 over 1 is 2. You simplify. Think in terms of simplify, 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 not multiply first and then simplify. Good. So then I am asked to present the equation in slope-intercept form, which I did. Then the last question is find the x and y intercepts. How do I find the x and y intercepts? So when x is 0, how much is y? When x is 0, how much is y? Very good. So now I have to make y equals 0. And let's see what happens. I have 0 equals 2/3 x plus 2. How do I solve this equation for x? I have to move 2 to the other side. Negative 2 equals 2/3 x. And then I have to multiply both sides by over 2. So this is 1. So this is simplified. So this is x equals negative 3. So x equals negative 3 when, x equals negative 3 when y is 0. So the other order pair is negative 3, 0. Here's negative 3, 0. And here is 0, comma 2. I have to connect and extend the line. So connect the 2 points and extend the line. Always write the name of the line somewhere. So I graphed y equals 2/3 x plus 2. Any questions on this problem? Okay, what happens here? How do we solve this compound inequality? No. It's not wrong. It's not wrong. It's just I don't want to do that. But you're on the right track. You eventually get the same answer.
Get rid of the fractions.
Exactly. I recommend that. So that will require multiplying both sides by 12 or 12 over 1. Very good. Because 12 is the least common denominator. Very good. So multiply this side by 12 over 1, multiply this side by 12 over 1, and multiply this side by 12 over 1. So when you multiply, again, simplify. That's the key. Simplify first. So I'll simplify. So I see a negative 8 less than. I simplify, and I see 6 times 2x minus 1. And I simplify, and I get a 3. Good. What now? I agree. So negative 8 less than 6 times 2, which is 12. 12x minus 6 less than or equal to 3. Very good. Perfect. Next step. Yes? Exactly. All 3 sides. Good. I'm adding 6 here, and I get negative 2. I'm adding 6 here, and I get 12x. I'm adding 6 here, and I get 9. Final step. What do I need to do? Exactly. So I have negative 1 over 6 less than x less than or equal to, I simplify by 3, so it's 3/4. I have to present this in interval notation. How do I present this in interval notation? X in the interval. Parenthesis, yeah, because it's yes, negative 1/6 and 3/4 with a bracket. I agree. Perfect. Excellent. Well done. Okay, let's look at the last problem. Does the graph represent the graph of a function?
Yeah.
By the? Excellent. Yes, by the vertical line test. Find the domain. I'm fine if you consider that the graph goes all the way. I'm fine if you consider that it ends there, but you have to show something, right? So if you present this, I'm fine, and then the domain will be what? Let's assume that that's the case. The domain will be right. Very good. Well, what about the range? Very good. Excellent. Oh, I'm so sorry. Forgive me. Sorry.
-4.
Exactly. From -4 to infinity with a bracket. Not the infinity, of course, but good. Very good. Find the x-intercepts. Present them as ordered pairs. Yes? Ordered pair. Very good. Excellent. And the other one? Excellent. Wonderful. Now I want to find f of 3. Kind of hard. I see. So hold on one second. So this is 2 and this is 4. I have to identify where 3 is. So 1, 1. So 3 is somewhere here. I will say -3. I'm fine if you approximate because it's not easy to read from here. Very good. Excellent. Find the x value such that f of x equals -2. No. What does the f of x equals -2 mean?
Y.
Exactly. Thank you. So at -2. So this is y equals -2, and this is x equals 3. So I see it crosses the graph here, and it crosses the graph here, and I have to read the x value. Not easy. I'm happy with an approximation, at least it's somewhere where I can see it. So if this is 3 and this is 2, I'm going to say roughly 2.6. I'm fine with any, as long as you show me the graph. Okay, here, obviously, so this is 4 and 6. 1, 2. Obviously, this must be 5. Would you consider 5 point? Good. I'm fine with that too. Good. Well done. As long as we are on the right track, I do not keep all quiz grades, but I want you to be prepared. And remember, do not do MyLabs Plus before you complete these problems. So first step is you have to redo the problems you do in class. This is your second step. And only then you can say, I think I'm ready for homework now. It's not going to happen otherwise. You'll have to go back to the book and flip the book all the time, and that's not part of, I don't think, consider that learning. Okay. So I'd like to look at some word problems here in section 3.5. On page 225, let's go with 73. Today's the 14th, right?
Yes.
So let's look at 73 on page 225. Let's read the problem, and as I read, I take notes. In 2006, The US population per square mile of land area was 85. 85 people per square mile. In 2011, the person per square mile population was 88. 88 people per square mile. Write an equation describing the relationship between year and persons per square mile. So in 2006 was 85, and it says X represents years past 2006. Number of years past 2006. So what am I given in this problem? I'm told that in 2006 we had 85 people per square mile on average. In 2011 it went from 85 to 88 people per square mile. Okay, so what is given in this problem? What am I given here?
There's going to be 2 points on the graph.
Absolutely. I am given 2 points, but I have to be very careful how I in identifying the independent variable and the dependent variable. Which one is the independent variable, which is going to be on the x-axis, and which one is the dependent variable, which will be on the y-axis? Without that, I cannot come up with the ordered pairs. What do you think?
The years are going to be on the X.
Of course, the time is always independent. So x here represents number of years past 2006. Can anyone tell us what will this represent as the first ordered pair then? Very good. What about the second ordered pair? Very good. Excellent. So now the whole thing repeats with 2, or reduces to what we just did a minute ago. So what is the first thing I have to perform or find? Very good. So 88 minus 85. Let's write the equation always so we don't forget it. So it's 88 minus 85 divided by 5 minus 0. So 88 minus 5 is 3. So it's 3/5, or if you want, 0.6. Now, without a measurement unit, this means nothing. What is the measurement unit of this slope? Or rate of change, also called the rate of change. The measurement unit. Is it feet? Is it kilograms? Is it money? Is it what?
People per square mile.
Exactly. Exactly. Per year, right? So the measurement unit of the top is people per square mile. The measurement unit for the bottom is year. So people per square mile per year is the increase. Okay? So people per square mile per year. So the measurement unit for a rate of change, or a slope in other words, has to be made, because it has to consist the measurement unit coming from the top of the fraction over the measurement unit coming from the bottom of the fraction. The top of the fraction is number of people per square mile. So that's the measurement unit coming from the top. Now 5 minus 0 is in measurement is year, right? So the increase every year is by 0.6 people per square mile per year. Okay, good. So now I'm analyzing the points I'm given, and I realize that I have 0, comma, a number. What ordered pair is that? When I'm given 0, comma, a number. Say it again. 0, comma, a number. Careful. Exactly. So I'm given the y-intercept. Every time I have x equals 0, comma, a number is the y-intercept, which makes me believe and think of y equals mx plus b, because I have b. b is 85. And the slope is 0.6. So the equation is 0.6x plus 85. I didn't have to go through y minus y1 and so on and so forth because I was given the y-intercept. Part B of the problem. Use this equation to predict the person per square mile population in 2020. So we're asked to find what in 2020? We're asked to find which variable is that? Yes, it's the y. So I'm asked to find y when x is how much? I can never put the name of a year in an equation. I shouldn't say it never, because some equations could require that, but it's rare. So what is x for 2020? Exactly. X is 14 years. So then y equals 0.6 times 14 plus 85. Can anyone give us this number? 0.6 times 14 plus 85. So we can move on. Now the next section, which is 8.1, is the same thing with this previous section 3.5. Exactly the same thing. It's just that it has more problems. And we're going to work on more problems right now from 8.1. Any questions on this? Do we have the number? 93.4 without a measurement unit. This means nothing. So what is this? Yes. People per square mile. Excellent. Thank you. Well done. Very good. Next, I'm on page, so this is 8.1, graphing and writing linear equations. It's the same thing, or linear functions. 8.1, graphing and writing linear functions. And I'm on page 517. I'd like to look at a couple of problems here. Okay, you feel free to choose if you want to. I'll be more than happy. I'd like to start with problem 46. We are asked to find an equation of a line passing through a point which is negative 2, negative 3, and also is perpendicular to a line whose equation is 3x plus 2y equals 5. So here's the scenario. I'm not graphing anything. I'm just graphing the idea, okay? Because I don't know if the line we're going to get will have a positive slope or negative slope. I have no clue. So let's say this is the line whose equation I don't have. I do have two pieces of information. I do know two things about it. I know that it passes through a point. So somewhere along the line, there is this point, negative 2, negative 3. And what else I know? That the green line is perpendicular to a line, 4 90-degree angles, whose equation is given as 3x plus 2y equals 5. Okay. I'm asked to find the equation of the green line. How do I think about this? What is the first step? I have a point, which is not the x-intercept. Which is not the y-intercept because it's not 0, a number. So it's just a generic point. And so I could use the point slope form, but I'm missing a key piece. What is the key piece I'm missing? Let's write the equation. And then I hope that you can tell me what is missing. I have negative 2, negative 3, which is my x1, y1. Which very important piece I'm missing, without which I cannot find the equation? Exactly. I'm missing the slope. So if I find a way of determining the slope, then I'm done. I'll put it in and just simplify. Good. What do I know about the slopes of two lines that are perpendicular? What is the relationship between them? You can use the relationship that I like, or you can use a relationship that It's the same thing, but it's slightly more difficult to say.
M1 times M2 equals
Exactly.
-1.
Exactly. Good. Perfect. So let me call this, let's say M1, which makes this line having the slope M2. So in this equation, assuming I have M2, can I determine my M1? Assuming I have M2, will I be able to determine my M1? Yes, I will divide by this number, correct? Is there a way of determining M2? That's the question now. Do I have a way of determining M2 of the given line? Do I have a way of determining the slope if I have the equation? Yes, if I solve for y. If I put it in this format, then I will be able to determine the slope. So all I have to do is what? To this equation. Solve for y. Once I solve for y, I will get the slope. So I take this equation and I move 3x to the other side. So then 2y equals negative 3x plus 5. And then, what is next? I'm trying to solve for y. Very good. So then I have y equals negative 3 halves x plus 5 halves. I divided both sides by 2, term by term. So I determined slope M2, which is negative 3 halves. So now can anyone identify the slope of the green line that I'm looking for? Which number multiplied by negative 3 halves will give us negative 1? It's the multiplicative inverse, which is 2/3. Only 2/3 multiplied by negative 3 over 2 will give us negative 1. Agreed? Okay, so then I have the slope, which is 2/3. Now I have everything. I have the slope, I have the point. All I have to do is plug it in and simplify. Are you with me? Okay. So therefore, I have y plus 3 equals 2/3 x plus 2. Do we agree with that step? I have y minus minus, which is plus. Then I have 2/3, and I have x minus minus, which is x plus 2. And right now I have to distribute 2/3 and then subtract 3. So when I distribute 2/3, I have this 4 over 3. 2 over 3 times 2 over 1 is 4 over 3. And I have to move 3. How do I add fractions or subtract fractions? What do I have to do? How will I add 4 over 3 to negative 3 or subtract 3 from 4/3? What do I have to find first? Which is, in this case, the only one. So 3 is the same, but 1 times 3 is 3, so I have to multiply the top of that fraction by 3. So what will I have here? So 3 over 1 has to change into 9 over 3. So what do I have at the top? 4 minus 9. So this is negative 5/5, negative 5/3. So then y equals 2/3 x minus 5/3. Can anyone tell us what is this? What does this equation represent? It represents the equation of the line that passes through 2 comma negative 3 and is for sure perpendicular to the line 3x plus 2y equals 5. Any questions? Any questions? I'd like to look at one more word problem, if that's okay with you. Any questions on this problem? Remember, you must redo it several times till you're able to do it on your own. Okay, so I'd like to choose 79 on page 518. 79 on 518. So let's read the problem. A rock is dropped from the top of a 400-foot building. After 1 second, the rock is traveling 32 feet per second. After 3 seconds, the rock is traveling 96 feet per second. That's the speed. Let y be the rate of descent, which is the speed, and x be the number of seconds since the rock was dropped. Write a linear equation that relates time x to rate y. What is given in this problem? Two points. Very good. Can anyone give us those 2 points so I can write them? Careful how we write those points. We have to clearly and carefully identify the independent variable and the dependent variable. So how will you write the ordered pair? 132, and the other one? 396. Very good. Okay, what do we do next? It's all the same thing, all the same steps. What is the next step? Very good. So 96 minus 32 over 3 minus 1. That is 64 divided by 2, or 32. It doesn't mean anything if I don't put the measurement unit. The measurement unit of a ratio or a rate of change has to look and is actually a ratio of 2 measurement units. The ratio of the top has the measurement unit for the top, and the measurement unit for the bottom is the bottom measurement unit. So what do I write? What is the measurement unit for the top? It's right here. It's written on paper. Good. So this is feet per second per? Yes, because it's acceleration. So we normally write it feet per second squared, which is the same thing. Very good. Okay, I have the slope. Now what? How do I proceed? This is the third problem that is the same. So how will I continue? What do I have to write? I cannot, because none of these is 0, a number. I'm not given the y-intercept. Yes, that's my second option and the only one. It doesn't matter which point you want to use, you will get the same answer. So the slope is 32, and I'm going to use 1, 32. I'm using the first point and, of course, the slope. Very good. And that will give us the equation of the line passing to the given points. So this is y minus 32 equals 32 times x minus 1. I distribute 32x minus 32, and I have to add 32 from the other side. So it turns out that the equation is 32x. So that's part A. Part B. Oops, I closed the book. Why did I close the book? I went to a different section. Okay. Part B. Use this equation to determine the rate of travel of the rock 4 seconds after it was dropped. So in part B, this was part A. In part B, we want to determine the rate 4 seconds after it was dropped. What do I have to do? Plug it in. Very good. So y equals 32 times 4. So then y equals 128. Measurement unit, please.
Feet per second.
Excellent. Very good. Very good. Questions for me, please? Questions? Anything you have for me, please? Okay, so remember, please, you have to redo the problems we did in class. Then you have to do all these problems to cement your understanding, and then homework. And you will have no difficulties in this class and the next class for sure.
Question. In the syllabus, you said that the homework was broken on 5% and 5%. Is that
Yes.
in your collective?
Yes, yes, yes. Now, if 10 problems are here and 7 of them are the same, choose 3. I'm okay with that. As long as you feel comfortable. If this does not give you confidence, this is not enough. So, redoing the problem we do in class, and as many as possible, as I said, if many of them are similar, I'm fine. As long as you know what you're doing and you say, I'm comfortable, I'm okay. But that's what math is. Without tons of practice, it will not stick. I wish I could say otherwise. Okay, chapter 4. Chapter 4 deals with systems of linear equations. And we're going to look only at into variables. Systems of linear equations into systems of 2 linear equations, I should have written, to be exact. Although section 4.4 has systems with 3 linear equations in 3 variables, we decided not to cover that part for some reason in this class. So it's not difficult, but we decided just to present systems of 2 linear equations in 2 variables. So let me give you an example. And I'm going to copy a problem from your book on page, so this is chapter 4. Let's take a look at page 256. I'm going to choose a problem from there. Let's say problem 38. And this is y equals x plus 5 and y equals negative 2x minus 4. Now let's discuss, first of all, and just try to understand what is a system. We know linear equations. Are these linear equations? Of course, they are linear equations. 2 variables, x and y, power 1, no products of variables, no other exponents, just 1. So power 1, 1, 1, 1. Okay, so definitely these are 2 linear equations. Do they have 2 variables? Yes, x and y. Okay, what is a system then? Well, a system is just telling us, well, these 2 conditions have to happen at the same time. If they don't happen at the same time, then the system has no solutions. So if I find a way, or if I find a solution to this, then I'll say the system has solutions, 1 or more. But if I am not able to find a solution, I'll say the system has no solutions. And we have a special name for that system. Now, before we even go ahead and try to solve this, I'm going to ask you in how many different ways to, by the way, if you graph this, how would you graph it? What is the graph of a linear equation? Is it a circle? Is it a parabola?
No, it's a line.
It's a line. So if you graph this, you will be graphing a line. If you graph this, you will be graphing a, very good. So this is a line, and this is another line. Good. So now let's suppose these are the two lines. In how many ways can they face one another? This is one way. No, not necessarily. So they intersect in how many points?
One.
Exactly. Right? Can two lines, straight lines, of course, can they meet in 2 points, or 3, or 4? No, they can meet in 1. It's one option. So every time I solve a system of two linear equations, this is one of the possibilities. This is one of the outcomes. Okay, here's the second one.
Parallel.
So in how many points will two lines intersect if they are parallel? No solutions, right? And here's a third one. In how many points do these two intersect? All of them. Infinite. Okay. So let's establish that on paper. Let's write it down, and then we'll start analyzing how to proceed. So possibility number 1, we call this unique. Just one unique solution. The system is called consistent. System is consistent. In other words, it has a solution, at least one. And equations are independent. Independent of one another. Good, so now we know the first possibility. Nothing else can happen. There are only 3 options. So I know what to expect. Unique solution, just one solution if you want to write, it's the same thing. System is consistent because it has a solution, at least, and equations are independent. Here's case number 2. No solutions. We do not have a name for the lines, unless you want to say parallel lines if you want. But for the equations, we don't have a name. System, of course, cannot be consistent. We call it inconsistent. It has no solutions. And of course, the third possibility, as we discussed, here is one line, and here's the other. And that is infinitely many solutions. The system is consistent or inconsistent? Of course. As long as it has one or more solutions, it has to be consistent. This time the equations will be called dependent. Equations are dependent. Now let's talk about how many methods we're going to study. Methods of solving systems of linear equations. We're going to look at 3. There are many methods of solving systems. But we are going to study 3 methods. 3 methods. 1, substitution. 2, adding. I like to call it elimination. You call it the way you like. And 3, graphing. Okay. I'm coming back to my system. I'm going to copy it here because it's up there. So here's my system. Y equals x plus 5 and y equals negative 2x minus 4. Any suggestions on how to solve this system? We have not discussed adding. We can use graphing, but I'd rather use substitution first, and then we'll graph it. And then I'll show you the other method, the third one. So, yes, please.
Substitute your random coordinates for y and solve for x.
No. y equals x plus 5, therefore this y gets replaced by x plus 5. That's the substitution. That's okay. So then we have x plus 5 equals negative 2x minus 4. The trick here is, maybe I should have said that, to form an equation with one variable. I don't know how to solve an equation with two variables. It could take me a lifetime to try to figure out where they intersect. I don't know how to solve an equation with two variables. But if I manipulate them somehow, which I did, this y and this y are the same. If I'm telling you y is x plus 5, then this y can be replaced by x plus 5. Now I created an equation with only one variable that I can solve. So I'm going to move 2x and I'm going to move 5. So when I move negative 2x, it becomes positive. When I move 5 to the other side, it becomes negative. You do it in any form you want. It's still x equals negative 3. Now what do I do with this? Because that's not good enough. Two lines have to meet in a point. I cannot say that these two lines meet when x is negative 3. I have to solve for y. So I'm going to go back here. Yes, and I get y equals? Good. So what is the ordered pair that we believe is the solution of the system? Yes, indeed. Do I know that for sure? Not yet. Of course, you don't need me to tell you whether it's correct, and I don't need you to tell me whether it's correct, because I'm going to go back and replace the variables with what I found in the original problem. If it works in both equations, then I'm okay. If it doesn't in one of them or both, then I'm not okay. The solution is wrong. What I claim is to be the solution, it's not. So negative 3 plus 5, is it 2? Yes. Negative 2 times negative 3. No. Negative 2 times 6 minus 4? 2. So now I know, and no one needs to tell me that this is indeed the solution. Now let's suppose after I did the algebraic work, let's suppose I want a graph. Okay, let's give it a shot. Let's suppose I am asked to graph. If I'm asked to graph on my scratch paper, on the side, I will still do it algebraically first. Because I don't want to, it's difficult to really graph if I don't have graph paper and so on and so forth, and then read that point, and then I have to make sure that it's the correct point, and I wouldn't do that. So I will first perform any algebraic method, either substitution or the adding method that I'm going to show you in a minute, before I graph. Let's suppose we're asked to graph, which we are in this section, actually. So I have y equals x plus 5, and I have y equals negative 2x minus 4. Remember, x and y-intercepts, x and y-intercepts. So I have y equals x plus 5. How do I determine the x-intercept? The x-intercept. How do I find the x-intercept? What is the equation of this line? It's the altitude. Yes, y equals 0. So when y is 0, 0 equals x plus 5. So for the x-intercept, I have to make y equals 0. How much is x? Negative 5. When I move it to the other side, I change its sign, right? So it's negative 5, 0. Now I want to find the y-intercept. How do I find the y-intercept for this equation? Very good. Make x equal to 0. How much is y? Very good. So y equals 5. So 0, 5. So let's graph. I plot the points, connect the line, connect the points, and extend the line. So I have negative 5, 0. I have 0, 5. Connect and extend the line. And this is the equation y equals x plus 5. I will repeat the steps for y equals negative 2x minus 4. So for y equals negative 2x minus 4, how do I get the x-intercept? So for x-intercept, I make 0 equals negative 2x minus 4. I move negative 2x, so it's positive 2x equals negative 4, so x equals negative 2. So the first ordered pair will be negative 2 comma 0. Now when x is 0, how much is y? Very good. I'm going to plot this line, the points, and then connect. So negative 2 comma 0 and 0 comma negative 4. This is the equation of the line y equals negative 2x minus 4. Now I'll have to try and figure out blah, blah, blah. However, I won't, because I did my work and I checked the solution. I cannot come up with another one. There is no such thing. So I'm not going to waste my time to try to figure out. I know it's negative 3, 2. So I'm going to say to you, look, my graph is so exact. I don't know how, but I just determined the solution. Of course I didn't. I did it algebraically first. I knew what it was, so I don't waste my time trying to figure out what it is on the graph. But of course it has to be somewhere, because if I make a mistake, then I know it's going to be an intersection here, and that's not the case, right? So it is somewhat on my graph. It's not perfect, far from being perfect. So it's negative 3, 2. Let's look at another substitution type of problem. For example, problem 12 on 264. Here is the system, and you'll tell me what to do. X plus 3y equals negative 5, and then 2x plus 2y equals 6. Think for 1